A Danish scientist named Hans Ørsted first discovered electromagnetism in 1819. Hans was a Danish physicist and chemist who discovered that electric currents create magnetic fields, which was the first connection found between electricity and magnetism. He is still known today for Ørsted's law. He shaped post-Kantian philosophy and advances in science throughout the late 19th century. The discovery happened when Ørsted noticed the needle on a magnetic compass moved when it was close to a straight wire carrying electricity. Before his electricity and magnetism were thought to be a completely separate phenomenon. But later on, an English physicist named William Sturgeon used his information to produce the first usable electromagnet in 1825. His 7-ounce magnet was able to support a piece of iron weighing 9 pounds. The next early pioneer was American scientist Joseph Henry, who improved on Sturgeon's design and created a 21-pound magnet that could support 750 pounds of weight!
An electromagnet is a type of magnet in which the magnetic field is produced by an electric current. Mechanically, an electromagnet is pretty simple. It consists of a length of conductive wire, usually copper, wrapped around a piece of metal. For current to be introduced, it comes either from a battery or another source of electricity, and that flows through the wire. This creates a magnetic field around the coiled wire, magnetizing the metal as if it were a permanent magnet. Unlike a permanent magnet, the strength of electromagnets can easily be changed by changing the electric current flowing into it. The poles of an electromagnet can be reversed by reversing the flows of electricity. But electromagnets differ from your run-of-the-mill permanent magnets, like the one holding your popsicle art to the fridge. As you know, magnets have two poles, north and south, and attract things such as steel and iron. Then similar poles repel one another. An electromagnet is the same way, except it is more temporary, because the magnetic field only exists when electric currents flow. Action!
But again, electromagnets aren't useless. Its impact on our society today goes very unnoticeable, as without it we would not be able to use as many as the appliances in our modern society, as they have a wide range of uses. Examples include communication devices like cell phones that rely on interaction of phone signal and a magnetic pulse produced by an electromagnet inside the phone. Another example is the magnetic resonance imaging machine, MRI machines, that use an electromagnet to produce magnetic waves that can penetrate the body to be able to see the soft tissue inside.
And action.
The doorbell can also be an example. When a guest pushes the button on your front door, a tiny electromagnet pulls a metal clapper against the bell, causing an electric loop, meaning the circuit is completed and turned on. The closed circuit allows electricity to flow, creating a magnetic force and causing it to become magnetized. Because magnetism is a force, magnets can be used to move things. Electric motors convert the energy of an electric current into motion by taking advantage of the interaction between the current and magnetism.
Speaking of currents, physicists use this thing called the right-hand rule in order to remember the directions of the magnetic forces. It is based on magnetic fields and the force they exert on moving charges. When charges are still, they are unaffected by the magnetic fields. But as soon as they start to move, the magnetic field pushes on them. But the direction that the field pushes on them is not the same as the direction of the magnetic field. To predict the behavior of positive charges, use your right hand. To predict the negative charges, use your left hand. If your thumb points in the direction of the velocity and your fingers point in the direction of the magnetic field, your palm points in the direction of the force.